Hi everyone, and welcome to this 8th episode of the Mandlbaur Insanity. Today we are going to destroy John's ridiculous claim that the product rule upon the cross product is, I'm quoting him, a stupid mistake. Let us take a quick look at his rack. He says that the cross product of the position vector and the momentum vector is equal to the simple product of position, momentum, and the sine of the angle between the two vectors. And he thinks that I'm talking about the entire scientific community, we forgot to take into account the angle. So he concludes that we are making a stupid mistake. So let us see who is stupid. Well, it is you, Mr. John Mandlbaur. We never ever said that the cross product between two vectors, which by the way is a vector, is equal to the simple product of the norms of these vectors and the sine of the angle between them, which is a scalar. A vector cannot be equal to a scalar. You are the one making the stupid mistake of equating a vector with a scalar. What we said is that the magnitude of the cross product is equal to that scalar. That's a huge difference. The information about the angle is already contained in the vectors themselves, by definition of vectors. For your information, the product rule is to be applied to the vector that results from the cross product, not to its magnitude. Tell us again who is stupid. Here is the mathematical and trivial proof that you are wrong, as usual. The position and momentum vectors can always be expressed in Cartesian coordinates. Once again, the information about the angle between them is already contained in them. So, let us take the definition of the cross product in terms of coordinates. We can directly calculate the time derivative of the resultant vector's coordinates without involving the product rule upon the cross product. The derivative of the first term of the x-coordinate is shown, and we can calculate the derivative of the second term and subsequently of the other coordinates in exactly the same fashion. No product rule upon the cross product has been used so far. But now, let us see what we get if we apply the product rule upon the cross product. All we have to do is to apply the definition of the cross product to the vector corresponding to the derivative of the position and the momentum vector. Likewise, we apply the definition of the cross product to the position vector and the vector corresponding to the derivative of the momentum. Oh, look what we have! This term appears here, and this term appears here, while this term appears here, and this one appears here. Same for the two other rows. So this proves that the product rule applied to the cross product is perfectly valid. Once again, you have been proven wrong, Mr. John Mandlbaur. Can you remind us who is stupid? By the way, let us take advantage of the validity of the product rule upon the cross product to explain to you, again, something that you have been refusing to understand for the last 10 years. If we calculate the time derivative of the angular momentum, we find that it can be expressed as the sum of two terms. The first one is the cross product of the time derivative of the position with the momentum. This is just the cross product of the velocity with itself, and is therefore equal to 0. The second term is the cross product of the position with the force, which by definition is the torque. So this proves that the rate of change of the angular momentum is equal to the torque. This means that angular momentum is conserved if and only if the torque is 0. Try to put this in your empty head, Mr. John Mandlbaur. Oh my God, every time this guy opens his mouth, it is to make more of a fool of himself.